Now let's say if we have set A, which contain the elements 2, 4, 5, 6, and 9. And we also have set B, which contain the elements 2, 3, 5, 6, 7, 9, and 10. So what is the intersection of set A and B? How can we get the answer? To find the intersection, we need to find out which elements are common to both sets. So both sets contain a 2, they contain a 5, a 6, and also a 9. So therefore, the intersection of sets A and B is 2, 3, actually not 3, but 2, 5, 6, and 9. And that's it. So that's how you could find the intersection of two sets. So now let's work on some more examples. You can pause the video and try this one if you want to. Let me use some different letters. So let's say this is set C, and it contains the elements 3, 4, 6, 7, and 10. And also set D, which contain the elements 3, 6, 8, and 9. So feel free to pause the video and determine the intersection of sets C and D. Go ahead and try it. So which elements are common to both sets? So 3 is common to both sets, 6, and that's it. So for this particular example, it's only 3 and 6. So that's the intersection of the two sets. So this is the answer. Let's try another example. Let's say set F contains the elements A, B, C, D, F, G, and J. And set G contains the elements A, C, G, H, and K. So what is the intersection between sets F and G? So feel free to take a minute and try it. So let's see which elements are shared between both sets. So both sets contain element A, element C, G, and that is it. So the intersection of F and G is going to be A, C, and G. So as you can see, finding the intersection is pretty straightforward. But now what about this particular example? Let's say set J contains the elements 5, 7, 10, and 11. And set K has the elements 2, 4, 8, and 13. What is the intersection of J and K? Now notice that there is no common element shared between the two sets. The elements in J are completely different from the elements in K. So in that case, the intersection of J and K is going to be empty. There's going to be nothing inside. So if there's nothing inside, if you have an empty set, you have a null set. So this is the answer. You have to use a Greek symbol phi. Now let's say we have set R, which contains the numbers 3, 4, 7, and 10, and set S, which is basically an empty set. What is the intersection of R and S? The intersection of a set with numbers and an empty set is going to be another empty set or a null set. So that's it for this one. Now let's focus on the second type of problem that we need to talk about, and that is to find the union of two sets. So let's say that set A contains the elements 1, 2, 3, and 4, and set B contains the elements 3, 4, 5, and 6. So what is the union of these two sets? When I think of union, I think of combining these into a larger set. Now notice that we do have some common numbers, 3 and 4. Now the union will contain everything in both sets, but 3 and 4, we're not going to write it twice, only once. So the union of set A and B is going to be 1, 2, 3, 4, 5, and 6. So we're going to write everything in both sets, but only write it once. So let's try some other examples. So let's say set C is 3, 5, 9, 11, and 13. And set D is 2, 3, 6, 8, and 12. Go ahead and find a union between sets C and D. Go ahead and try that. So all we got to do is just write all the numbers in C and D. So let's put it in ascending order. So we have a 2, a 3, there's a 5, a 6, there's no 7. So we have an 8, a 9, there's no 10, but we have an 11, 12, and 13. And so that's it. So that's the union of those two sets. Here's another example. Let's say that set J contains the letters A, C, D, and E, and that set K contains the letters A, B, F, E, and G. Go ahead and determine the union between J and K. So just like before, all we need to do is write all the letters. So we have an A, a B, C, D, E, F, and G. And that's it for that question. Let's say that set X contains the numbers 2, 5, 8, 12. And set Y, let's say, is an empty set. What is the union of a set with numbers and an empty set? Well, the empty set is not going to add anything. It's like saying 15 plus 0, that's going to be 15. So therefore, the union of set X with an empty set Y is going to be the same as set X. It's 2, 5, 8, and 12. It's not going to change. But the intersection of a set with something and a set with nothing, it's going to be an empty set. So just something to keep in mind. Now, here's a question for you. Let's say if set A contains the numbers 3, 4, 5, and 7, and set B contains the numbers 2, 4, 5, and 8. How can you determine the intersection of A and B and a union of A and B and represent the results using a Venn diagram? So circle A and circle B in its separated form. Set A contains the numbers 3, 4, 5, and 7. B contains the numbers 2, 4, 5, and 8. Now, the intersection of these two, I'm running out of space here, is 4 and 5. 4 and 5 are found in both. But to represent that using Venn diagrams, what we need to do is put the two circles together and draw it this way. So this is set A and set B. So in the middle is the intersection of A and B, which contains these elements, 4 and 5. Now A also contains 3 and 7, and B also contains 2 and 8. But 4 and 5 is common to A and B, so we put that in the middle. Now the union of these two sets is basically everything. It contains the numbers 2, 3, 4, 5, 7, and 8. And I'm running out of space. So this entire system with the two circles represents the union of A and B because it contains all the numbers 2, 3, 4, 5, 7, and 8. But the intersection is limited by this region here because it only contains the elements common to both sets. So hopefully this helps you to see the relationship between intersection of sets and union of sets as it relates to Venn diagrams. So that's it for this video. Thanks for watching and have a good day.